Hello everyone, this is Jiacheng from ECE department, and I'm recording this for the ECE6303 homework 2. So the problem here, we need to define this function here basically. So as professor mentioned in the lecture, so once we need to get the results for time slot, we need to define the arriving time for the bus or the number of people arriving here. So we need to use the Poisson distribution to calculate the probability. And we can see here's the definition. It's very kindly to give us the definition here. But we need to get the lambda from the known knowledge here. The trick is here, we need to derive the number of people coming in this time slot to at least. So the task here is to convert. I will change another color, at least. To number of customer. So that this is the most important part in this problem. So here we know at least one customer we can derive as greater or equal than 1. And we can see here we can compare to add 0 people. Sorry, I will use person here. 0 person. So this is basically 0. These two events combine. We use another color P of this event. These two events together equals to 1. Okay. So and this is independent. Then we can separate this equation into 2 parts. First part, second part. First part is here. Second part is here. Then, as we know, at least equals to 0.3. This equals to 1. And the Poisson, we can use the Poisson right here, the K is 0, T is 2 minutes. Okay, I will highlight this one, okay. Then we just plug in this 2 variables to get the results. So basically this question become very easy for now. We can easily use E minus lambda t equals to 2, lambda t equals to 2, k equals to 0, k equals to 0, and the probability equals to 0.7. Then it's very simple to get the lambda. And for this question, so this is actually this scenario here. We can easily just plug in t equals to 3, k equals to 0. And this one is 10 minutes, t equals to 10 for this problem. And here we need to focus on this part. I will to erase this to make it easier to see. Okay, at least 2. Okay, so this is basically we can use this similar function, then we can derive our new function. Okay, then this part is very easy. I will close this, and this function becomes at least 2. This is greater than 2 plus 0%, 1 plus, sorry, this is 0 and 1%. 1, okay. And then the whole probability of these 3 events becomes, and they are independent, becomes P at least 2 plus P 0% plus P 1%. They equals to 1 also, and we can calculate it from the equation we just derived. I use another color. Okay, then we can get this value. This is what the question asks us to do. And the last question seems more simple. And we just need to use t equals to 1 and exactly 1 customer, k equals to 1. Okay, that's it. It's basically tricky to use this first function here. Then we can derive everything from this equation because they are independent, and the probability of these 2 independent events becomes 1. Then we can get everything. Let's see the result here. Okay, the question is here. So basically, I convert the in 2 minutes, no one came becomes 1 minus this happens. So this is already known. Then we can get the lambda here. And then we can plug in this lambda into the Poisson distribution, and the t equals to 3, no one came, k equals to 0. Then we can get the result here. And this question is similar with the first question, and I basically transfer it here. Then it's in 10 minutes, no one came, 1 person came. Then we can get at least 2. So this is greater than 2. And we can get the results. The last question is very simple. Just plug in t equals to 1, k equals to 1. Then we can get the final probability right here. Thanks for listening. Thank you.